Good morning, good afternoon. Welcome everyone to the GeoPanel Reimagining Sustainable Cities and Communities by Leveraging EO in the Future of Work, Retail, and Other Sectors. I'm Patricia Cummins with Esri. Esri is a GIS and location intelligence company and a longtime supporter of GEO. And Esri is also proud to be recognized as a GEO Associate member. And I'm very honored to be facilitating this panel session this morning. We're fortunate to have three fabulous speakers with us today to share their perspectives from the private sector and the public sector. They will tee up our discussions this morning by sharing their experiences, their visions, and a vision for a collaborative path forward. And after brief remarks from each of them, we'll move into a lively panel discussion. So please queue up your questions in the Slido chat and we'll take them all at the end. I'll provide a brief introduction now of each of the three panelists and direct you to their bios on the platform for their complete story. We're going to start out this morning with Gaetano Volpe, who's worked for ICT sector applied to space for the last 20 years. Combining his passion for technology and his passion for space. In his vision as innovation and CEO of Latitudo 40, Gaetano is working to create a new model of analysis for the urban environment using remote sensing combined with in situ data, IoT sensors, and crowdsourced information. Our second speaker is Derek Angere, and I have to give special credit to Derek, who is stepping in due to a last-minute conflict for our scheduled speaker, Vivian Mehta. Derek Angere is with Locate It, a remote sensing and GIS. He's a remote sensing and GIS application expert, where he undertakes projects and tasks in Earth observations, integrative mapping and modeling of land surface dynamics, process and workflow automation. He has a degree in the study of geomatic engineering and geospatial information systems. And then our final speaker this morning will be Dennis Mwaniki and he is a spatial data expert at UN Habitat's Data and Analytics Unit, where his day-to-day responsibilities include coordinating activities around geospatial data production, methodological developments, and supporting countries and cities in the integration of Earth observations and geospatial information techniques into urban monitoring processes. And he currently leads the UN Habitat's global activities on the production of data for three critical SDG 11 indicators, which are reliant on EO and geospatial information. 11.311 on urbanization trends, 11.211 on access to public transport, and 11.711 on access to open public spaces. I'm sure you can see how all of those are going to fit in this conversation, this panel discussion on reimagining sustainable cities and communities. And with that, I am going to kick things off, remind you to put comments into the chat window. And we are going to kick off with Gaetano getting us started here. I'll stop sharing. Okay. Gaetano, welcome.
Good afternoon. Thank you for this opportunity. I already presented my company a few minutes ago. So I would like to give in this brief presentation some reason that we analyzed to decide the investment in the urban planning and urban monitoring solution. We are a company that is involved in the space sector, and it's clear that to identify a market with a low competition, we analyzed the market of the urban sector, and it's clear that it's a market with a lot of new technologies and new opportunities. So there is also because in the 2050, more than 2/3 of people will live in the city, and so there is a high pressure to create, the high challenge to create a sustainable and resilient city. So to define this project, the project of our company, we define what is a sustainable city. We tried to understand. We came from a technical point of view, and from my side, from business administration. So I am not a technician, not an architect, not a urban planner. But what we understood is that in the sustainable city, there are two dimensions: an enabling dimension and an outcome dimension. So it's clear from the enabling, there is the capability to plan and to define financial sustainability of this city. And the outcome of this plan is an improvement of the city, an improvement of protection of natural resources, but also the reduction of climate change, the impact of climate change, and also inclusiveness and livability. So increase the average quality of life in the city. That is a good target to reach. So discussing with several customer partners, we understood that to create a sustainable city is a cycle. And this cycle that starts from knowledge and analysis and move to the vision and priorities, then the intervention plan, and then the monitoring and evaluation. Data are key element to building an effective and efficient model. So as sustainable city, a sustainable place, a smart place need to use data. So we decided that with our expertise in Earth observation, remote sensing, image analytics, and artificial intelligence, we can give a contribution to this sector. We can create a solution that can offer a support in stage 1 and stage 4 of this virtual cycle. Because it's clear, Earth observation imagery is widely available. It's very simple to connect this data in the last 5 and analyze the evolution in the last 5 or 10 years. It's a powerful tool to support geospatial analysis, and it's a technology that offers the trend analysis and the KPI construction. So we analyze what is the available data at the moment. So in Europe, we are based in Europe, and we use the open data of the European Commission. And it's clear that we have Sentinel-1 with radar images that can help us to analyze the geometry and subsidence of the ground, but also other aspects. Sentinel-2 that give us, we created for this a land surface temperature algorithms that give a very precise measurement of the temperature on ground and the classification of the area. We used also Sentinel-5P to insert in this model the air quality analysis. And it's clear that for a city is always important to use also commercial very high resolution images. So from Airbus, Planet, Maxa, Spacewheel, everywhere. We use this to urban object classification using machine learning and artificial intelligence. So building, pools, solar panels, cars, containers, ships. And our objective, our vision is to create a very useful dashboard and mobile apps that can help public decisor, urban planner, but also citizens. So the logic of our vision is that satellite Earth observation can give an answer how to optimize green areas in a town. What is the area that can have a high risk for people, or where are warmest area in the city? So this is, for the citizen, we are working on a mobile app that offers the possibility to schedule a route in green areas with low pollution and with a better thermal comfort. I lost one slide, sorry for this. The problem is that all these very good things are not easy to apply in normal cities. In the last 3 months, I discussed it with more than 50 cities in Europe, in Italy and Europe, related to smart project, open data project. And in no one of them, the Earth observation is in the top priority for data collection. They are using sensors, they're using crowdsourcing information, but it's very complicated. They never spoke about Earth observation. We say, why? Because it's complex. Earth observation is a very stable technology, simply available, but extract information from data is not so simple. So the logic that we propose to leverage the Earth observation for sustainable and green cities, probably is necessary to change the paradigm. Modify from create very simple cloud software as a service solution. This is an approach that the industry is using in this moment. Several companies are working to automate all the back office activity, all the value chain product, and offer very simple approach to the users, to the urban planners, to the people that need to know something about the city. So the logic is, some key is that this platform need to be very simple to use, like WordPress or Shopify. Take the example from other sector. The logic of a cloud platform can move the investment from the CapEx to the OpEx. So every city can use this platform with a low investment. And so not only the large cities or the rich cities can start a project based on the Earth observation, but we have a democratization of the Earth observation. So everyone with a couple of €1,000 can start this project. And the other aspect, we are working with several other startups and SME to create a library of a ready-made application. So everyone can use a service composer, something that is very simple to use to identify the block that needs to analyze. And one suggestion is that these platforms need to be open for the integration of the city data, because it's clear that satellite data are really important, but cannot give all the answer to the city. So just to conclude, to go to the conclusion on my brief presentation, my idea and my vision when I speak with our customer, with stakeholder, is focus on solution and not the technology. This kind of customer, probably sometimes have no competence or knowledge to understand what the complexity of remote sensing. Always propose to this customer to start with an MVP, a minimum viable product, or a proof of concept. Then we can reach the best solution with so more than one iteration. The logic is to have a multi-parametric and a multi-temporal approach. So satellite data need to live with city data, with open data, with other data. And so my mission is that the logic is that the satellite is the only technology that can start from the past and can help to understand the future. The other aspect is that this technology is well implemented in the market, can become the starting point to understand the scenario, to set goals, and after the implementation of the plan, to monitor the evolution of the action and the results, and to give more transparency and more information to the city. I hope that to be in time. So thank you. This is my contact. If you have some question, I'm very happy to answer you.
Thank you very much, Gaetano. That was a lot of information in a quick amount of time, but I really like your takeaway slides there. And in particular, what struck me is the focus on the solution, not on the technology. And I think that's a transition that across the geospatial and EO communities, we need to make that transition to help reach the decision makers. So thank you very much. And we're going to move on now to our second presenter, and we'll have Derek Angari share with us some of the work that Located is working on. Derek, thank you for joining us on short notice this morning. We look forward to your remarks. And please unmute yourself. Derek, you're still muted.
So thank you, Pat,
You're
for
welcome.
the introduction. So my name is Derek Ongeri. I work at Locate IT as a space applications technician. I'll be taking this presentation on behalf of my colleague Vivian Meta, who won't be joining us, unfortunately, due to some personal issues. Now, reimagining sustainable cities for communities by leveraging Earth observation in the future. So a brief introduction into our company. Locate IT is a company based in Nairobi, Kenya, and Particularly, our mission is to provide highly sophisticated yet simplified space technologies and geomatic products that serve and offer solutions that provide impact in society. In our DNA of the company, we have the 3 I's framework, which is driving using information to make interventions and to drive impacts, which I think is very key for urban areas in the future. So again, it is a fact that by 2050, most of the world population will live in cities, about 2/3, and this calls for a transformation in the way we build and manage our urban spaces. So to make urban development sustainable and to create careers, business opportunities, safe and affordable housing, and building resilient communities within the urban centers, will need heavy investment, of course, in connectivity and movement, that is in transport, creating green spaces, and improving urban planning and management, and in participatory and inclusive ways for our communities. So a critical condition for the achievement of these improvements is the effective and efficient use of dynamic and disintegrated data, especially for decision making. That is at least what we believe in as a company. And I also agree with Tano for focusing on solutions, because the solutions provide the decisions that drive this impact. So Earth observation is going to play a big role in terms of providing this information. It will be it will enable informed decision, and we'll also have data-driven decision making for our urban environments. So this presentation particularly will focus on our vision for the future in terms of environment, in terms of clean energy, and in terms of how work is going to be impacted in the near future based on the use of EO technologies. So we know that already cities are struggling with environmental degradation, particularly, I think it's all cities around the world, even here in Africa. And we have several projects based on Earth observation data in terms of trying to help cities to manage their environmental degradation. Here in Nairobi, Kenya, we are working with the Metropolitan Service for Nairobi, and also Nakuru and Vihiga County. So in terms of environment, we know that the technology is moving towards knowledge hubs, as opposed to what we used to have traditionally, where it's the spatial data infrastructures, where you have data about cities, but now we have these knowledge hubs that host Earth observation data and applications that people are leveraging on to build tools for quick, easy, and less expensive monitoring of urban environment. So changes in air quality, we have things like Sentinel-5P, we have land cover changes, we have built up indices and vegetation loss and gain indices also coming from Earth observation, water quality indices, and for water abstraction in urban areas. So all this EO data will inform most city managers looking to deeply understand the trade-offs between natural resources and urban development. So, and we also need to quantitatively assess some of these changes and provide evidences so that can inform policies, and in terms of lowering emissions and increasing, let's say, house density, so that you can expand green spaces, and also in waste management. So we are seeing an uptake of Earth observation technologies by city managers, particularly here in Africa, and I would say Kenya, because for the few that we have approached in terms of counties here in Kenya, there is some keen interest to pick up the technologies in environment. So also in clean energy, we know that most cities are unique when it comes to the implementation of renewable energy. and it's not really the same. And in such, you require a lot of data to make informed decisions in terms of providing clean energy for cities. And so in the near future, we see that Earth observation will play a key role in solving these puzzles for renewable energy for most urban areas, in terms of maximizing by mapping the Earth and using the Earth observation data, we can maximize the renewable energy production, because some of the key parameters that are needed in this and in implementing some of these renewable energy projects can be derived from Earth observation data. That is soil, something like solar irradiance, wind speed, precipitation, climate conditions, and geothermal data. We, in partnership with some of the local partners, and including organizations like GIZ, which play a key role here in terms of clean energy, we've had some engagements with them, and also trying to improve the life of urban dwellers in terms of promoting clean energy. So the parameters that are needed for this clean energy should be accurately estimated, and the quick and easy way to do this is by applying this Earth observation technology. So with the move towards clean energy, Earth observation will still play a key role in terms of promoting clean energy. So in terms of urban infrastructure, currently, I know we've had a lot of developments. Even as we speak now, we have mapping applications on traffic. And what is to note with this application is the ability to use historical traffic data to predict the traffic flow, how it will change over time, and the integration with data from the ground and from crowdsourcing for incident data. So this can inform local departments of transport in terms of managing the traffic within cities. But particularly for professionals who are developing infrastructure and managing infrastructure, there are new, less expensive ways for doing their feasibility studies. Can be provided by satellite imagery and GPS surveying, all that have been enabled due to these satellite constellations that we have. So this information has become vital to understanding existing circumstances and with unprecedented accuracy, and it allows the designers, decision makers, and stakeholders to share the same eyewitness evidence in discussion of proposals and solving problems. Here in Nairobi also, we've had a problem with traffic flow, so there was a call to make an assessment of to solve the traffic problem, and some site suitability analysis was required, and this intended to use Earth observation data so that the sites for bus terminus and entry points into the city could be chosen with informed and evidence decisions. So in terms of improving efficiency and enabling diversity at work, over the past few years, we've also seen that a lot of uptake in Earth observation technologies in private sector and also in government. So most of these organizations are looking to improve their efficiencies by leveraging on Earth observation technologies, focused predominantly on improving an efficiency at work. Of course, you couple this with things like Geo AI, and you can make informed decision and reduce wastage in terms of, especially when you're talking about logistics. We've seen the uptake of Earth observation, and this is going to go on a continuous trend, particularly even here in Africa. So with most of the development of Earth observation technology focus also predominantly on transfer of knowledge and partnerships. So institutions are increasingly becoming aware of the technologies and creating programs and strategies to capture the knowledge of for employees and to manage workflow transitions in both in-person and increasingly in remote engagements. And also the adaptation of EO for sustainability in urban area promises greater diversity in workplace across all industries to bring together as a mix of all ages, experience, cultural backgrounds, and gender and diverse skill sets. Then the Earth observation, this is worth noting that the increased visibility of women in STEM courses, that is science, technology, and engineering, is also becoming quite, EO is playing a big role. So we have they are building capacity. The building of capacity has also led to the creation of networking groups for most females. And advocacy groups like Women in Geospatial and Women in GIS are likely to continue growing. So bringing in that diversity and in terms of gender, in terms of the workplace. So I think my presentation will be short and end at that point, and I would like to thank you all.
Thank you, Derek, for a wonderful set of examples of your work. And we definitely look forward to following up with some more questions on those. Particularly, I thought your comment about seeing the uptake in and interest in this from city managers is something we want to explore. Okay. But let's move on now to our presentation from Dennis, who will bring the UN Habitat perspective, a global perspective, but definitely focused on working with our cities to make them more sustainable going into the future. So Dennis, please share your work with us.
Thank you very much, Pat. And good morning, good afternoon, and good evening to everyone, depending on where you are. I'm going to try and bring a global context into what both Gaetano and Derek have been discussing. And specifically for me, I want to talk a bit about what we are doing at UN Habitat in terms of application and use of Earth observation and geospatial information for SDG 11 monitoring. And I like the heading of this session because it's called Reimagining Sustainable Cities and Communities by Leveraging Earth Observations, because that is also the same goal name for Goal 11, which is the SDG 11 on Sustainable Cities and Community. So I'm going to start here by showing the importance of cities in the sustainable development agenda, and within the context of the 17 goals and there are about 169 indicators. We have a lot of cross-cutting things, which with one goal affecting things in another goal, or in one indicator in a different goal affecting what happens in another goal. So that interconnectedness of the indicators and the targets in the SDG framework have the cities at the center, the urban areas at the center, because and as Derek was mentioning, is that the world is even today more urban than rural. So it means that what we do in the cities to respond to the needs of the current and the future generations will significantly already affect what the current generation is. The majority of the populations who live in the urban areas. We also have some other things which make cities really at the center of sustainable development, like they consume most of the Earth's natural resources. That is estimated at about 75%. That is a big problem because some of the resource consumption patterns for cities have been identified as not being sustainable. So how we address the consumption patterns in cities will significantly affect how the world drives towards being sustainable. We also have cities, as they consume all these resources, they also produce a lot of waste and a lot of greenhouse gas emissions. And this again have a direct impact on how sustainable our world is likely to be. Then a lot of also a lot of the GDP. Despite all this consumption, the cities also a lot of concentration of the economic activities, with an estimated about 80% of the global GDP concentrated in urban areas. So this has a direct link again to the dream of and the goal of promoting prosperity and also reducing inequality. So if you have reduced inequalities in cities, then you're likely to have more equitable distribution of wealth across the population spectrum. So here, just to contextualize that, cities are really at the center of the SDGs, and one of the famous quotes is that is from the UN Secretary General, Under Secretary General in 2015, where he said that the battle for sustainable development will be either be won or lost in cities. And here it just really is just showing you how that is important. So SDG 11 itself, which is titled Make Cities and Human Settlements Inclusive, Safe, and Resilient, and Sustainable for All, it has 10 targets, which are divided into 14 indicators. And these targets span across areas. We have a target on housing and informal settlement and slums. We have a target on transport. We have a target on planning processes and the sustainability of plans. We have targets on cultural heritage. We have targets on disaster reduction, air quality and waste management, as well as on open and public spaces. But we also have other policy provisions which are supposed to drive the attainment of some of the targets, and also promote the drive towards sustainable urbanization. So within this framework for 14 indicators, we have very specific indicators which rely on the use of Earth observation, despite the fact that all the indicators, whichever indicator you want to pick from the SDG monitoring framework, at the end it will have a spatial component. So you'll want to know, for example, when you talk about in SDG 1, you talk about reduce poverty. Where is the poverty? So where are the actions supposed to be? When you talk about environmental indicators, you want to see which environments are most vulnerable. So that in itself gives every single indicator in every single target and every single goal just a spatial location, which then means that whatever data we produce or whatever data is generated from different sources, at the end it needs to have a spatial component, which then in a broader manner of speaking, that ties directly to the spatial component, the relevance and the high need for the use of geospatial information and the point-based kind of data production. And here within these frameworks, especially for the SDG, we have the operational sort of mandate that is given through the guidelines and the SDG operational documents. Some of the two most important being the SDG indicator framework in itself, that requires and recommends the integration of new sources of data, because the monitoring framework acknowledges that it is not possible to produce data for all the indicators using traditional sources like censuses and surveys. We actually, some indicators really require directly use of Earth observation and geospatial information to not only produce the data, but even to analyze it and make sense of the patterns. The other one, of course, is the document on that guides the production of official statistics. It's called the Fundamental Principles of Official Statistics. It also requires that data should be, as much as possible, disaggregated by geographic location for the different content. And for the sake of this today's discussion, I just want to focus on 3 or 4 indicators which require not just geospatial information to show what is happening, but they actually require the use of Earth observation to actually be able to produce the indicator value itself. And the most critical ones here is the indicator within SDG 11, include SDG 11.3.1, which looks at how cities are urbanizing spatially versus how the population in the cities and urban areas is changing. The other one is the 11.7.1, looks at how cities provide for open and green areas and how accessible these spaces are to populations. Then we also have where when looking at housing, where we have the indicator 11.1.1 looks at the sort of settlement of morphology or typology, whether it's a slum or informal settlement. But we also look at transport and provision of public transport across cities, which is indicator 11.2.1. And here, just starting with the 11.3.1, the one on urbanization, I just want to show you here directly now, bringing down what Gaetano and Derek was saying, how we are actually applying Earth observation and geospatial information to produce data for this specific indicator. And this slide full of many things just shows you the inputs for the indicator and the kind of computation that is required. The main thing I want to point out here is that this is one of indicators which actually goes back in time. It seeks to understand how urban areas have been growing over time, as far back as is practical from the existing satellite imagery. But also it can help local governments and cities and countries to actually also be able to predict what is likely to happen. And I know Gaetano was talking about this in his slide presentation. So here the key inputs really for production of data for this indicator. The first most important one includes the historical satellite imagery. And here we are grateful that we have archives like Landsat, and currently we also have Sentinel that are producing information that can actually be used to measure this indicator at a reasonable resolution of and quality of accuracy. Then we use this satellite imagery to extract information on the built-up areas, which is the kind of the core of measuring the indicator itself. We also use Earth observation, extracted products, and what here again is the extracted built-up areas to define the cities. And we've had a lot of discussions at the global level on how we harmonize how cities and urban areas are defined. And two of the most significant inputs which there has been consensus is that we need to look at how much built-up areas there are in an area for it to qualify as urban, but also sort of the population and the concentrations of population. So that is the second component, looking at identifying what the urban area is. So you use your extracted products, but also the processes themselves are geo-reliant. Then you need to disaggregate population for all the, at least for all the spatial indicators under goal 11. There is a requirement to disaggregate indicators or rather population data, not just by age, sex, gender distribution, but also bring it down to a level that could actually help you to measure what is accessible and what is not accessible. And for this one, we are using like data from, again, Earth observation, like from built up areas and the distribution of the settlements to disaggregate population to smaller grids or even built up areas to help us to compute the indicator. Then the rest is just using this process, then you can actually be able to compute this indicator by integrating not just the Earth observation component, but also bringing the statistical component. These two, they're very critical for any SDG measurement, especially under SDG 11. The second indicator that is highly reliant on the use of Earth observation and geospatial information, for us, I want to emphasize that we are not just talking about Earth observation, but we also have the component of geospatial information and the processes that lead to production of the statistics, which then includes that intersection between the spatial aspect, but also the traditional statistical aspects like the census data and other high resolution information. So for indicator 11.7.1 really looks at the open spaces, one, where they are, how well distributed they are within the city, and then also looking at how accessible they are, which is measured as a walking distance of 400 meters from the places where people live to where the spaces are. So here we're using Earth observation and geospatial information to not only identify the spaces, but also to run the actual process of computing the indicator. So for this indicator, usually the best source of information is the land use plans for cities. but in many cities that this information is not available, either at the correct accuracy or resolution, like temporal resolution. Most of them would be either very old, or they are not publicly disseminated, or they cannot be used for this kind of measurement. So in cases where this information is not available, we have recommended the use of either satellite imagery or base maps from different organizations like OpenStreetMap, but also integrate into this a ground verification to identify which spaces are actually open spaces and are actually accessible for people. Then from there, we run the network analysis in GIS and use that to compute the indicator. The other thing that we are doing, and some interesting work we have been doing with the South African National Space Agency, is to try and apply Earth observation and geospatial information to try and differentiate different settlement types, like formal versus informal. So all settlements in different countries have different structures and different patterns. So we've been trying to identify unique identifiers that can be applied across the board from satellite imagery to be able to help us to understand which areas qualify or are likely to be informal settlements in a given city or country. Then that information can then be further built upon using other information like DHS data and census. And this just shows some of the intersections we've done by overlaying the extracted data using a set of morphological variables with the data produced by DHS on vulnerabilities, which traditionally UNHabitat has been using to identify areas which are informal. So it really shows a very high value for use of Earth observation and geospatial processes to help us to understand the different settlement typologies in cities and countries. Just before I'm going to close in this slide.
We're running short. There's so much information to cover. If we could wrap up soon, we can take a question, Dennis.
Okay, yeah. So just to conclude, is that for within the reporting framework for SDGs, it's not just about companies and research organizations producing data, but it's also about enabling the countries and the cities to actually produce data, because it's the ones who use it, but they're also the ones who are responsible for reporting on the progress. And I would like to close there. Thank you very much.
No, thank you very much. Definitely the leadership from UN Habitat is critical in helping all countries and cities work toward achieving these critical SDGs under Goal 11. So with that, thank you very much, all of you, for your fabulous remarks. I think there's so many topics we could dive into. I think one of the key ones that came through is on all of these was the need that there's a lot of data out there, that there is technology now like we've never had before, and computing power. But the challenge is still, how do we connect, how do we translate, get technologists to shift from just being technologists to being those advocates who can communicate to the decision makers. So it can be, the data can actually be applied, moving to that knowledge, actionable information. And I think oftentimes technologists struggle with that, but the successes each of you have talked about, some of you figured it out. I know Derek was talking about knowledge hubs and how they're coming on board, and the uptake with city managers. And Gaetano, you were talking about solutions, and Dennis, you're talking about really laying out pathways that can help technologists get to the solutions, to the answers that the decision makers need. Can you each talk about something that you think was kind of key to a success of bridging that gap? Gaetano, we'll start with you.
Yes, this is a really good question, because this is a question that every day we put to ourselves: how to convince urban planner or public authorities to use satellite images. And the logic I also presented, the logic is not to speak of, as you underlined, the technology is not the key, because our customers or our interfaces typically have a very low knowledge about this technology. So the logic is describe a dream, describe a story, present the solution. So the logic just yesterday, we met an important city in Italy to discuss about the application of Earth observation to their plan for renew the city. They are planting more than 3 million of new trees in the city. And the logic is, we said, okay, but this is after our discussion. They said, oh, but satellite is fantastic because I have a very big knowledge about public green, but I have no knowledge about private green. So using satellite, I can put my trees where there is less totally green area, not only public. So I can improve the quality of life with the same investment. I can better improve the quality of life of people in area with high level of urbanization or with less private green. This is one idea.
So, but what I hear you saying, Gaetano, is it was talking with them to find out what is one of the key issues, what is the problem they're trying to solve, and understand that, and then relate it back to EO and the solution.
Yes, the logic, we never speak about remote sensing, because when the starting point is we are here to offer an opportunity and a solution to better know your city and your space.
Right.
And
all right. We're running out of time, so I want to get have time for Derek and Dennis to respond as well. Thank you, Gaetano. Derek?
Okay, thank you, Pat. I think one of the things that has increased this uptake is of Earth observation technology actually is simplification. And like I said, we are moving from, let's say, spatial data infrastructures where you will get all tools, gather information, and maybe refine, like calling it spatial, remote sensing, and all the technical terms. We've just boiled it down to what we are now even calling decision support systems. So basically you abstract all the technology, and then you have maybe, let's say, a simple web interface for a service that will enable someone to better understand their environment. And also to allude to what Dennis was saying, part of the projects that we've undertaken is actually taking these underlying international standards and technical methodologies for reporting these SDG indicators, and then putting it on a service that is intuitive and very easy to use for some of these city managers. And that is very welcomed for them, because they can see, I think, the intuitive nature of how, let's say, maps speak to them, and also couple it with some of the statistics that they are really interested in. And of course, the starting point, as Gaetano had mentioned, is to really understand what is it they're trying to solve. So much of the technical work is left to us to brainstorm and to make it simple for them to use.
Exactly. I'm going to have to cut you off there, Derek. I'm being told we're running out of time, and I want to give Dennis a chance to respond, and then we'll have to wrap up the session. But Dennis.
Yeah, thank you very much, Pat. And I just start by re-emphasizing what Derek just said, that a lot of decision makers are not really very keen to see the images as raw things. They are really interested in what kind of information comes from that, and the ability to use that to relate with that to what they know is the problem. For us, what we've seen work very well with the uptake is the SDG monitoring framework. One has expanded the scope and the requirement for reporting, very important. And the second thing is that as the less developed countries uptake these technologies and show what is possible to actually produce using these technologies and limited capacities, then we're also seeing a lot of interest with the country-to-country learning. And people always ask you, where has this worked? How well has it worked? And now we are able to actually show that in this country they started with 0, and they can actually be able to say this is a problem for us, and this is how they are using these technologies to solve the problem.
Yes, I wish we could dig in more to that whole kind of shared learning model, and learning from one another and taking lessons from one success in a city to another, and get that peer-to-peer networking going on, not just among the technologists, but also in the decision makers. But with that, we are out of time, so I'm going to have to wrap up. I will encourage our audience to use the conference platform to reach out to our speakers for follow-up questions and discussions. Use that chat. Reach out to any of us. As you can see, we're all passionate about the work that we do, and we welcome the opportunity to continue this dialogue. But I want to say a virtual thank you to all of our speakers for preparing your remarks, and Derek, special thanks for stepping in on short notice. We certainly wish Vivienne and her family well. And with that, I'll wrap it up and enjoy the rest of the industry track and the rest of Geo Week. Thank you very much.
Thank you very much, Pat.
Thank you, Pat. Thank you.
Bye.